Okay, let's get started. So, just to quickly check up a few questions from yesterday's homework. Number 6 here. 2 to the power of 3 times 2 to the power of 5. Everything in bracket raised to the power of 2. Tell me one way to do this. One way. Shrenik?
You can first simplify the things inside the bracket.
Yep, so it becomes
58.
Good.
And then you have to multiply the exponent by 2.
Yep. Perfect. What's another way that I could have done this question? This is the ideal way, but what's the other way, Edward?
Multiply the power by 2.
Right. So if I do 3 times 2, I get 6, and then 5 times 2, I get 10. So then 10 plus 6, I still get that 16. This will tie into what we're doing later today. Remember, this is also raised to another exponent, so that's why we multiply this and multiply this. All right. This next one, simplifying inside the bracket, we get 7 squared raised to another cube. 2 times 3 is 6. Okay, not 5 again. Okay. Next one. Okay. In some of the answers yesterday, I saw this as part of the answer. That's totally fine. Okay. In the answers, some of the format was like this. Okay, it's the exact same thing. So they did it in one step. You might have done it in 2 separate steps. So 8 minus 2 is 6, and then 6 plus the 4 is 10. Okay, so it's the same thing. So 3 to the power of 10 times 5, you get 3 to the 50. Okay, last one right here. Somebody lead me through this one. Tenzi? Huh?
8 plus 4.
Yeah.
For choose exponents. 2 and 3 can simplify, so we keep that. And then so the 12 multiplied by 3, 36. And 2 multiplied by 3, 6. 2 to the 36 power and 3 divided by 3 to the 6 power.
Perfect. Can I simplify any further?
Actually,
I don't think so. No. Okay, so the question asked is simplify, not evaluate. So you would just leave it like this. I cannot do any further because the base are different. So that's all I will leave it to. Okay, and then of course Tenzi is trying to see, no, I believe we could. Okay, let me know by the end of class if it could be reduced any further.
I mean, depends on the definition of simplification.
Simple, yeah. So I don't want evaluate. So simplified with the powers. This is good enough with me. Okay. So 2 word problems. Notice there isn't much word problems in this whole package. That's because there really isn't much you can do with the exponents. So if on the quiz, these are the type of questions you'll see if there are any. Okay. If the population of rabbit doubles every year, how many rabbits will there be in 3 years if there's currently 7? Okay, so anybody? Doubles every year for 3 years. So what does that mean? Grace? 2 to the power of 3, right? So, but what about the 7? Right. So you always have to start out with your initial value. So 7 times, I'm doubling it, I'm doubling it, I'm doubling it. So after 3 years, this is what it will look like. If I were to simplify this, I could simplify it as 7 times 2 to the power of 3. All right. Okay, have I answered the question? No. All right, what is my final answer then? 56 rabbits, right? I will release your the last test answers today before the end of class. And then you can see what mistakes you made. Some of you lost marks because of units. No matter how many times I stress it. Okay. And last one. You go back in time and tell your parents to buy into Apple. Your parents wisely listens to you and invest $1,000. If they really trust you, they would put more than 1,000. Since then, the value of Apple has tripled 4 times. What does that mean? Yeah. 3 to the power of 4, or times 3 times 3 times 3 times 3. Okay, how much would your $1,000 investment be worth? So, as Shrenik said, this means 3 to the power of 4. So does that mean?
81.
Yeah. So does that mean that my answer is 81? That I made $81? No. What am I missing in my expression? Yep. The initial value. Don't forget, you have to times your initial value. Otherwise, you don't know what. If I only invested $1, yeah, I made $81. But because that 1,000 initial, I get my final answer 81,000. So imagine if your parents really listened to you, or you were more persuasive and told them to invest $1,000,000, then you'll be very rich. Okay. Good final answer? What am I missing? What is my unit here? Dollars. Dollars. Oh yeah, and on the last test, I saw some people write the $sign in the back. I did take marks off this time, but that's French. So when you do the $sign with only one line in it, that's French.
But the question only has one line in it.
Oh, that's the font. Here, there you go. Supposedly, but I'm not that picky. I'm not gonna take half a mark off for like one line. No, it's the only one line. Am I that mean? Okay. So, all right. So that was the homework from yesterday. Those were probably the only harder questions. Okay. So now that we know what to do when we're dealing with numbers, we're gonna do the same thing, but with variables. Okay, variables. What are variables? Anyone? What are variables? Okay, Aiden, what does Google say variables are?
It is any factor, trait, or condition that can exist in different amount of types. That's about it. Yeah.
Or how about variables in math?
It's an alphabetical term that represents an unknown number.
Right. Yeah, not as but represent something. So a letter representation for something. Most of the time, it is to represent a number. All right. Good. So let's first recap the exponent rules. When you multiply two numbers with the same base, what do you do to the exponents? Yeah, add. Okay. What about when you divide two numbers? What do you do to the exponents? Simon? Subtract. When you raise exponent to another exponent, what do you do to the exponents, Grace? Multiply. And when you raise anything to the power of 0, equals Felix? 1. Good. And negative exponent means what to do with the base? Yep. Flip the base. That's right. Okay. So now let's just apply the exact same rules, but on variables. So instead of 2 to the power of 5, I'm doing a to the power of 5 times a to the power of 3. So what's my base? A, yeah. And then I just add the exponents because that's what we said we do. So it's simply a to the 8. Okay. What about example 2? I get b to the, you can just shout out the answer. B to the 4. Good. Example 3, c to the d. And
restriction d not equal to 0.
oh, good. I like that. If d does not equal 0. What if d equals 0? Then what would your answer be? 0 to the power of 0? Let's see. 0 to the power of 0. Error. Da, da, da. Yeah. Hey, good. Very, Tensi, that's very good recognition. All right, nobody ever mentioned that, so that's very nice. Okay, and then example 5.
E to the negative 2 over f to the negative, or f squared over e.
Yep. Okay, yes. So negative exponent means to flip the base. So instead of e over f, it's now f over e to the exponent positive 2. So when you simplify it, I get f squared over e squared. The key for this one is, remember, your exponent applies to both your numerator and denominator. Okay, so now let's try a little bit more complicated, just a tiny bit more. What's different with this example 1? There's a number. What's that number called? There's a coefficient. Good. So there's a 2 and a 6. These are coefficients. But as Aiden said, these are just numbers. So what can I do with just numbers? Multiply them. So any coefficient I can simplify. So 2 times the 6 gives me the 12. So I could simplify that because it's just numbers that I'm multiplying and dividing. All right, so then this one I get 12a8. All right, what about example 2 then? My coefficient's 30 and my coefficient is 29 here. Yep.
You simplify to 10 over 9.
Yep.
And then you subtract the exponents, you get b to the 4th.
Good. Okay, so I could write it like this, 10 over 9 times b to the 4 on the side like this. What's another way I could rewrite this? Yeah?
10b to the 4th over 9.
Right. So I could also rewrite it like this. They mean the exact same. Okay, and that's because when you multiply something as a whole, you multiply to the top. Hey, this one, example 3, what do I get in example 3? Edward? Sorry? Example 3? Mm-hmm. Perfect. All right. So the key right here is your coefficient is inside the bracket. A lot of time people forget to apply the exponent. Just like right here, when we said we had to apply the exponent to everything inside the bracket, to every coefficient, every number. So same rule applies right here. You have to do the negative 2 raised to the power of 4. And because the negative is inside the bracket, that's why it's positive 16. So you get 16, C, 12. Okay. Example 4 is a little tricky, just a tiny bit tricky. What do you get in example 4? Kingsley, what do you get in example 4? Connor, you're next. This one?
If the numerator is 9,
Example 4. 4. Yeah. Right. Okay, that -5 is not part of the zero exponent. So when you simplify it, it's -5 times 1, which gives you -5. Okay, Connor. I have a example 5. I have a negative exponent.
numerator is 9 squared.
Okay. And what about your denominator then?
Coding. 16 squared.
Good. Okay. So flip the base. And then again, don't forget to apply your square to everything in your numerator. So it's 9f squared and 16e squared. This is a common mistake that people do. I see it all the time on the exam. People only do 3f squared and 4e squared. Right. Okay, very last one. Phone?
You multiply 4 and -2, you get -8.
Yep.
And then x squared times x to the 6 is x to the 8.
Good.
Y to the -3 times y to the y squared is y to the -1. And then z to the 6 times z is just z to the 7.
Right. Where did why is it 7?
Because you're adding z to the 6 plus 7. So z to the
1. Right. That's right. When there's no exponent, there is still an exponent. It's an exponent 1. So then the 6 plus the 1 gives you the 7. But this is a good answer. But Phil, how would you rate it as the better answer?
So y to the -1 is just 1 over y. So you write -8x to the 8, z to the 7th over y.
Perfect. Okay. So this is the better answer. -1 exponent means 1 over y, which means when you multiply these by 1, 1, it's just on the numerator, and then the y is left in the denominator. Good. Okay. Any questions? Okay, so that's all. That's all for this whole package. You learned everything you need to know for your quiz on Monday. So for the rest of the class, just finish up the whole package. Remember, on Monday, bring your 1, bring your computer. 2, study for your quiz. 3, complete this whole package, which I will be checking. All right.